All right, we'll see. Let's see how it works. Okay. So let me ask you this. If there's something we don't know, so for example, if we didn't know the average amount of pollutants in the water in a certain city, what would you do? What could we do?
Get some samples.
Get some samples. That's always in statistics class. That's always a great answer to the first question in statistics teacher asks. Get samples. Does everybody agree? So if I go to a certain area and I'm concerned that either there's some runoff or there's just pollutants in the air that settle on things, I could just take some soil samples, some water samples. Are you guys kind of with me? I have no idea what the mean is, what the average number of pollutant particles are in there. You with me? I have no idea what the standard deviation is, correct? You all with me? So a really good question then is, if I do take a sample and I find a sample mean, is there a way for me to figure out how confident I am about that, and then how do I communicate that to other people? Does that make sense? If I said to you, if somebody asked me, hey Jeff, what's the average student make on your final? And I said, yeah, they make about an 80, give or take 20 points.
It's pretty bad.
Is that very useful information?
No.
No! That's shit!
So range
That's from 60 to 100. You basically just said, they make a grade. You guys kind of with me?
Mm-hmm.
So that's me communicating to you that I wouldn't be very confident in my answer. Maybe that's the first semester I taught, right? Now I should have a much better, more focused answer because I have more data to pull upon. So my confidence level has gone up. Are you guys at all with me? Are you guys with me? Okay. So this whole idea of confidence in our observations is key to this next chapter. Has anybody looked at the title of the next chapter? You know, like, were we supposed to? No, I was just wondering. Confidence intervals, it's crazy. Okay. So, the first kind of thing we're going to do, just to kind of ease into the idea. So, it really sucks if we do not know the mean and we don't know the standard deviation, because aren't most of the things we've done recently built off of those two things? So we don't know either of those things. We're kind of like, are you guys? Okay. All right. So each section of chapter 8 is kind of predicated on knowing less and less, basically. Well, let me say this. 8.1 and 8.3 are both related. 8.3 is assuming we know less than we do in 8.1. 8.2, I don't know if you guys noticed on the homework sheet, I do 8.1, 8.3, 8.2. And the reason I do that is because 8.2, just to warn you guys, we're going to have a different chart than the z-score chart for section 8.2. Things get so freaky in section 8.2 that we need a whole new chart. Are you guys at all with me? Okay. And I don't say that to make you freak out. We're only going to have 2 more charts. That one and then one more after that. Okay. Okay, so here's the idea. So what we're going to do is we're going to say that we know the population standard deviation. And this is a real life situation. So for example, this is a silly example. Let's say that we know the population standard deviation length of dolphins. Are you guys all with me? For a certain type of dolphin, are you with me? We know it. Let's say that, I don't know. So there's a certain type of dolphin. Even more specific. Certain type of dolphin, and we know the population standard deviation in their lengths, right? And we have a hypothesis. We're like, I think there's this island in this area where the dolphins are known to be. And we're concerned because this island might have a lot of runoff, pollution runoff. And we're concerned about what is that doing to, is that having an effect on the dolphins' growth? Is it stunting their growth? Does that make sense? So let me just put that out there. Let's see, that's the hypothesis. What do we base it on? People have reported that dolphins seem to look shorter than normal, so we're going to go in there and actually do a formal study just to see what's going on. Are you guys kind of with me? A little bit? You're not with me at all?
Yes.
Go ahead, keep going. Okay. So we're going to go out there. We're going to get in a boat. We're going to go out there. We're going to get a dolphin. We're going to tag it. We're going to measure it. And we're going to let it go. We tag it, of course, because we've already measured it.
You don't,
Okay. All right. So let's say that I go out there and let's say I get let's say we take a sample of 48 dolphins. But let's say that we go in, we know the standard deviation, we know it. How do we know it? Because all the dolphins have already been studied. We already know the general population standard deviation. Let's say we know that to be, make up a number, Jeff. Here it comes. Here comes the number. Look at this number. There it is. 8.11 inches. Sure. Can we stop for a minute? So we have a concern that some dolphins might be they might be being affected by pollution in the water around a certain island.
These are baby dolphins.
These are adult dolphins, so it makes sense to compare their lengths. Are you guys with me?
Oh, sorry.
Standard deviation is 8.11. Yeah. We know the standard deviation of all dolphins, right? So we're going to go in and we're going to find a sample mean. So we took a sample of 48, and let's say the sample mean that we get is 91.09 inches. If I remember correctly, we'll see. I'm not going to pretend to be a dolphin biologist because I am not one. That is a very hyper-specific job title. And that is not me. I think this is what it is. Okay. Now, real quick. What if we knew that the actual average length of dolphins was 93 inches? Is just knowing this enough to go, holy shit, they're being affected?
Yeah.
Think about it.
No.
Where does this come from? Where did that number come from? A sample. Random variability suggests that I could have just picked a bunch of smaller dolphins, right? I need to weigh this against the variability of the samples, right? You guys kind of with me? No? Okay.
It's within two standard deviations.
We got to be careful. We have to be careful. 8.11 inches. Can somebody tell me what that represents? 8.11 inches. What does that represent?
That's the standard deviation of the population, not of the sample.
Be more specific.
Individual.
There it is. 8.11 inches is how spread out individual dolphins' lengths are from each other, from the mean, right? We'll stop for a minute. I love the looks on your faces right now. Okay, so sigma always came from individuals. Are we working with individuals right now? We're working with a group of 48, correct? And I want to know, how weird is that group of 48 compared to that? So chapter 9 is going to be the full-blown what's called hypothesis test. It's going to be 5 steps. And that's where we could test the claim. So the claim would be, or we claim the average length is less. So then we take a sample and then we can test the claim with statistical analysis. That's not what we're doing today. Today we're doing surface level, first blush, real quick. We're going to construct an interval that kind of communicates how far off we think the sample is from the real mean. So let me say this. Would anybody in here put money down that the actual average length of dolphins around this island is different from this?
Oh, yeah.
I'm a teacher. I would put all my money down on this being, right? I would put a lot of money down on this being different, on the actual average being different. Or you all know this shit. Any sample you take, is almost definitely going to be different from the actual average. It would be really weird if it was perfectly the same. Okay. So here's the idea. Stay with me. This is not quite alternate universe Florida level of weird. So I've already taken you further than we're ever going to go again. This still gets a little weird. Okay. You all agree with me there's a real mean of these dolphins somewhere, correct? Okay. And I know this would be a real mean for groups of 48. How do I know it's going to be normal?
It's more than 30.
If I plotted all the samples of 48, it's greater than 30, so I know it's going to be normally distributed, correct? Okay. Normal enough. Kick ass. 95% of all the samples of size 48 have means that fall how close to the real mean? Yeah, and to be a little more specific, it's 1.96. Let's do this. Does everybody have the z-score chart?
What was the percentage? 95%?
95%, yeah. So I don't know if you guys remember the empirical rule kind of rounded things to make it easy to remember. So 95% was within 2. We just rounded, come back to me. Thank you. We just rounded 1.96 to 2 to make it easy to remember, right? So let's verify this though. If there's 95% in here, how much is out here? 2.5 on each side. I love it. Look up 0.025. Do I have a z-score chart? That would be amazing, Jeff. Can you steal somebody else's?
Right here.
Yeah, one I could borrow? Because I want to show that thing you found.
That was the thing I used them for.
Yeah, you used it too early. But so if I look up 0.025, Eric, what are you guys getting? 0.025. Ooh, look at how perfect that is. 1.96. Are you guys with me? There's 0.025. Where'd it go? Where'd you go? You're here somewhere. There it is. Perfectly 0.025, right? Doesn't happen very often. You guys with me? So,
Which
go
data,
ahead.
which data is this? Is this the averages versus other averages?
If I took every sample of size 48
Okay.
and I went up and down 1.96, I would catch 95% of those samples. So 95% of the time, a sample I picked will have a mean that is within 2 steps away from the actual mean. Let me say that again. And again, just to let you know, this has happened before. I am deriving a formula actually. So right now we're talking about the concept. Then we'll make a formula. So we're in the derivation stage, which is always a weird place to be, right? Because as a student, you're like, which part of this shit is what I'm going to have to do? We're not there yet. This is the concept. Yes?
We're dealing with the sample. At no point do we need to do the conversion for the standard deviation.
We will. That's going to come up. Yeah. So I haven't talked about that standard deviation yet at all within any context of work. It's just there.
Will it be
Right.
the same one?
No, we're going to have to change it like you just alluded to. Yeah.
Oh, no.
Okay.
More new formulas.
Now, real quick, guys. So we got, so I don't know what the actual average of the dolphins around this island is. Yes? That's what I want to figure out. There's no way in hell we're going to measure every damn dolphin that lives around this island. You guys agree with me? Or, you could try, but it might take a while. Okay. So we're going to take a sample. 48 is a pretty good sample because it's bigger than 30 for one thing. Okay. So let's say that we take a sample and it happens to fall here. You can do it again, Jeff. There we go. There's a little hat went way the hell up. Sorry. So let's say I take a sample and I get my sample mean to be right here. Yes? So that's going to happen how often? If another group came and took their own sample, it could fall anywhere on here, but how often will it show up in here? 95% of the time. So ready with me so far? If you then, if you take a sample, what are the chances that it doesn't show up in there.
5%.
5% of the time. So how confident are you that your sample would end up in there? 95% confident. Okay. So here's the work we do. We do something very strange. Do we know what this is?
No.
That's the whole freaking point. By the way, it's not this, is it? I really should do this to make sure you understand. And not only is this a mean of sample means, this is a mean of dolphins around the island, which could be different from the mean of all this kind of dolphin. Yes? Because they all don't live around this one island. Okay, I really want you guys with me. Okay. So what we do is let me put this down here. Does this formula look familiar?
Yep.
Yeah, especially if I can write. So what we do is, I don't know this, do I? So I'm going to take a sample. Which means what's going to happen to this guy? That's going to happen, correct? Are you with me? Now here's the funky part. We cannot build an interval around this. Why not? Because I don't know this. So what we do instead is we build an interval around this.
Around what?
Around x bar. So instead of using mu, I'm going to use x bar because that's my next best guess at what the average is. I'm going to go up and down enough steps so that I'm as confident as I need to be. If I want to be 95% confident, I'm going to go up and down 1.96 steps. So, real quick, if somebody came along and got a mean that was outside of here, when they build their confidence interval, it will not contain this. How often would somebody's confidence interval not contain this? That's the same question as, how often will somebody's mean fall outside of here? We already answered that question. 5% of the time. So if I had 100 different groups go out, I mean, this is like, everybody's freaking out about this dolphin for some reason. So 100 different companies send groups out, and we each take our own samples. And these poor dolphins are just, have a lot of bling. They have a lot of, from all the different groups measuring. I've already been measured, sure, what the hell? Okay, let me go. Right? You guys kind of with me? 100 different groups go out and take their own samples. 95 of them is what I would predict would get sample means that are within this. What does all that shit mean, Jeff? I don't know. Oh, yeah. All right. If I take my sample mean, whatever I get, and if I want to be, for example, 95% confident, z would be 1.96. Why is there a plus and a minus here? Because I want to go up and down, right? And how did I prime you for this? Max and min usual values. And also within one standard deviation of the mean. So we're used to going up and down so much. I guess I'm all with me. No. Okay. Yes.
Our sample isn't going to be symmetrical within the data the way the unknown mean will. Doesn't that mean that our plus and minus distances will not be identical? We're not going to go up the same number of
Confidence
steps
intervals
as we would go down.
are surface level investigations. There are issues with the accuracy of what I'm looking at. That's why if I want to prove something, I'll do chapter 9.
Okay. So our
Or show evidence for
our
something.
plus and minus distances will be identical. Hypothetically, I know it's not a real.
Yeah,
sample,
if
but
I
seven
know
up, seven
this, the population standard deviation, no matter what my sample mean is, it's going to be the same. The plus or minus part?
down. Yeah.
To be the same.
You're gonna go the same distance in both
Yeah,
directions.
All right, let me see. Let's do a concrete problem. This might have happened very subtly, but that is the formula. This here, sorry, I keep pointing to different monitors. This here is the formula to create a confidence interval. Why is it an interval? Because it goes from something to something. There's a minimum and a maximum to it, right? So it's an improvement on just saying, so if I told you, let me ask you this. You guys have all heard of the website Rate My Professors?
That's how I found you.
I'll never forget, I was on the East Coast, 2004, I think is when it started. Somebody came around and saying, have you heard about this website called Rate My Professors? And the next day, I could see my colleagues had gone in and rated themselves. And one guy was like, essence of the essence. And, anyway, that's one level of thing, right? And I always tell students, if I don't get some bad reviews, I'm not doing a good job, right? So I'm kind of happy. Last time I looked at some bad reviews, I'm like, okay. I don't know if you guys understand what I mean by that. There are some students who come in with wrong expectations, and if they don't give me a bad review, I'm not doing my job. Okay. Feel about that as you will. Now, obviously, I don't want bad reviews, but I don't care really. There's another website that actually gives you grade distributions of professors.
You told us this is the
I might.
state level.
Sure, state level. State doesn't go into that.
Oh.
State's more surface level. This actually drills down to professor by professor, right? So you could actually go to this website, look me up, look at my 160 classes, and see my historical grade distributions.
Wait, like the grades people earn?
Yeah, so you'll see what percentage of A's they gave, what percentage of B's, C's, D's,
But like
F's.
they earn that much.
What do you mean?
It has nothing to do really with you.
Well, it's the grades I gave. Yes.
It's a reflection of them too.
No, I agree with you. I'm just saying you could look me up. You can look somebody else up and see their grade distribution. Are you with me?
You could argue how generous a teacher is.
Yeah, but it's both.
Yes. Now listen, guys.
Your tactics could have changed over time.
Some of you guys might not have been going to college long enough, but you get to a point where, let's say that you looked at Rate My Professor, the schedule, everything is the same between these two teachers. Right? There we go, okay. Everything's the same between these two teachers, except when you look at the grade distributions. Let's say this one teacher gives, let's say you're at university, like we talked about earlier, what's passing in university? D. Everybody with me? So say one teacher gives anywhere from a D up to a B. Right? So they both give an average of C, but one teacher gives from a D to a B. Yes? And this other teacher gives from an F to an A. Are you guys with me? I haven't done this with you yet, yeah?
I think you touched on
I
it
did?
or very early in class. You
You
discussed
can do it
this
again.
with us.
Yeah.
It's good to know.
Short-term memory loss. It happens.
So, anyway, it's good to know the spread because, for example, when would you take the person that would give B through D when you know you're going to suck in that class?
You've
And
low
then, as a
confidence.
student, there were some classes I'm like, I'm going to suck in that class. Are you with me? And then when are you going to take the A through the F when you know you're going to kick ass? Now, I took this class, B through D, knowing I was going to kick ass because it was the only one they offered. And sure enough, I get the highest grade, and they got a B. This guy was waiting for some god to come, and then they get like an A-. Okay, enough of that. So this is really just the next level up from that. It's creating this spread. So not, if I just tell you the average that I saw in a sample, that doesn't communicate how certain you are about being near that. So if I said I give anywhere from an A to an F versus anywhere from a B to a D, that extra information is good to know. If somebody said, how many people do you think is coming? And they said, about 100. And they're like, give me a range. 20 to 180. And this other person was like 90 to 110. Who's more confident?
The second person.
The second person. You guys kind of with me?
Imagine ordering food for that.
Oh.
Anywhere from 20 to 180 people.
Yeah, exactly. Right? Okay, you guys all with me? Maybe? No? Okay. So let's do a concrete example of this stuff. Jeff, I wish I had paper. Paper. Somewhere I have paper.
Right?
I brought no paper. Somebody want to get some brownie points? Chella? Okay.
Where to before you
I'll record those later.
Okay.
So coming back to the same example. Let's say I got all this stuff. N is 48. Sigma is 8.11. We take a sample of 48, we get an average of 91.09.
Race what's on the board.
Oh, yeah, thank you. Yeah, in general, do that for me, because I'm not used to using projectors. So, to construct a confidence interval, heretofore affectionately known as a CI, because the less I have to write, the better for everybody. Come back to me. Come back again. There we go.
Okay.
Let me stop for a minute. So to construct a confidence interval, here is the formula that we use. The one we just constructed, the one we just made. This is, again, this formula is kind of silly. It really is just this one. I don't know this, so I take a sample to find x bar. I took a sample, so this has got to change. And I want to go up and down, so this is plus and minus. Now, one thing I forgot, can I borrow your z-square chart again? Most of the time, we construct confidence intervals at 95% confidence. So we did it earlier, we looked in the middle, blah, blah, blah. But if you look at the bottom of the positive z-square chart, is anybody ever worried about what the hell this means? If I want to be, give it a minute, it's got to do its thing. There we go. Okay. If I want to be 95% confident, I go up and down 1.96. If I want to be 99% confident, I go up and down 2.575. So a really good question is, what if I want to be 100% confident, Jeff?
You can't.
You go up and down infinity.
Yeah.
Is there a reason that 95 is used more than 99?
Historically, it's just where we, again, how do we define unusual?
Two standard
It's just-
deviations.
Why? Because that's 95% of the data. So it truly was just kind of arbitrary to a certain degree. 5% seemed to make sense. That's what most people would agree. If something had a 5% chance happening and it does, that's unusual. Yes? You guys kind of agree? Now, real quick. I've already talked about this part. If you're working in a nuclear reactor, right, nuclear power plant, and you have these little gauges, and there's like green and yellow and red.
Let's
Are
not
you with
wait
me?
for 5%.
Huh?
You said let's not.
Yeah, exactly. If that needle starts to move towards the yellow, I'm off my ass way before it hits yellow. Yes? So in that case, how am I defining unusual? I'm defining unusual to be maybe half a step away from the mean. Are you guys kind of with me? Why am I defining, I really want you guys with me. Normal operating for a power plant. Let's say it's solidly in the green. Yes? The minute it starts to move up towards the yellow, I'm off my ass. I'm not going.
It's fine.
I got time.
Even if it's yellow, you can wait till it's a little bit in red.
You'd be amazed how many refineries don't
I know,
react in
I
time,
know.
and
I
there's
don't
an
wanna get into that.
explosion.
What would we do? I would hope most of us would get our ass the minute that needle starts moving towards yellow. Yes, we have defined unusual in a very narrow sense then, because the consequences of being wrong that it truly is unusual are catastrophic in that case. Yes. If another situation is, when do I mow my lawn? Who gives a shit?
Unless you're in an HOA. it doesn't
I'm
matter.
not going to be every day like, watching my grass with the hit the mower. No, so you guys kind of with me. So it depends. So we need to have some flexibility in how we define unusual. So before today, unusual was 2 steps away, which kind of matches up with the 1.96 for 95% confidence. That's the most commonly used confidence level. But depending on the situation, I might want to use a different confidence level because I might want to be conservative in case something might blow up, right? Or let's say this, just to get you guys ready for this. In chapter 9, one kind of problem we're going to look at is how do you prove to the fire insurance that your insurance rate could go down because they built a new fire station. One thing you might have to show is that response times have gone appreciably down. Who's going to set up the level you must pass so your insurance goes down? The insurance company, yes? what are they going to set their rates? What are they going to set their test at? Very high level, right? Meaning you're going to have to show something really far away from what was happening before. It's got to be really, really different. We'll get there. So the general thing I want you to understand right now is the different confidence levels very often relate to different reasons why I want to define unusual difference, right? Yeah, maybe. Most of the time, it's 95%. So let's say I'm making a 95% confidence interval. What did we figure out the z-score was for that situation?
1.96.
Okay, and now I've got everything I need for this, yes? X bar was 91.09. Now it's a race against, when do I lose my voice? 1.96. Yeah, it's going to take it a moment to. So 91.09, give or take, this many steps. So the sigma was 8.11, and I have to divide by the square root of 48. So would you all agree with me that this number, whatever this number is, I am subtracting from and adding to this?
Yeah.
So this seems to be a good first number to get in your calculator. There were times when I've had students ask me where the plus minus button was, and I just had to kind of smile at them. So this is two, it's like the quadratic formula. You gotta do both.
I mean, it'd be cool to have one.
Can somebody figure out what this is?
Oh, just that portion.
Just that part, yeah.
2.294.
2.294? Can I get independent verification?
I just went and did the whole thing now.
Right. Not that I don't trust Nick. I trust Nick very much. But I like independent verification.
Square root of 48. 2.294.
Yeah.
Are you doing 3 decimal places?
Well, let's see. Did I bring any? You can have mine.
Did you only want 3 decimal places?
2.294?
If you only wanted 3, yeah.
Yeah. That sounds good. In general, I want this to be one more than this. I want this, the number of places here, to be one more than the number of places around. That's all. Yeah. Yes?
You wouldn't want us doing the, I mean, I did enter it that way, but you don't want us doing the whole thing at once to avoid some round off error?
I mean, sort of, but here's why I do this. This number is how much I think I'm off by. This is what we call the error. So this is what we think it is. This is our best guess. Give or take this. So this is how much we're allowing this to be off by. So 95% of the time, the actual mean will fall between two numbers. What are those?
93.384.
All right, that's the upper one, 93.384.
88.796.
Now, this is kind of cool. I could just act all cool and say I meant to do this, but I didn't. So here, watch this. Does anyone remember the actual mean of dolphins?
93.
Yeah. With this, and again, that's from here. That's not from the Googles. Okay, so I don't know what the real thing is. I think it's around there. Does our confidence interval say it could be 93?
Yes.
Yes, good. So is this evidence that the dolphins in this area are shorter than average? Could they be 93 or more? According to our interval.
Yeah.
Could the mean be above 93?
Slightly, but yes.
Totally. So is this evidence that they are shorter than the average dolphin? Nope. What would be evidence if our interval would have been 86 up to 92? That would have been evidence. Because does this even include the possibility that they're 93 inches long? So I really need you to understand. We would be 95% confident that the actual average is less than 93. That would be evidence that it is less than 93. Is this one evidence that their actual mean is at less than 93? No, because it could be 93. Do you guys see that? Yes.
I personally didn't catch that. You might go over one more time.
Certainly.
Yeah.
So we went into this knowing that the normal healthy dolphin has an average length of 93 inches. We took a sample, and sure enough, our sample length was less than 93. But that's not good enough. It's just a sample. So if I construct a confidence interval, I can kind of get a feel for where the real mean could be. The real mean could be anywhere from 88.8 up to 93.4 inches long.
It was based off the real mean. I was basing it off of the sample mean.
No. Yeah, now for the first time, I'm bringing the real mean in to compare it to what we built around this guy. Yeah. Okay, maybe. So again, when you can kind of compare this to trying to prove a criminal case. What is the whole thing about trying to prove somebody guilty of something?
Reasonable doubt.
Yes. So this would be a reasonable doubt. What's the probability that the actual mean is not wouldn't be in here?
5%.
5% chance. That's a reasonable doubt. This one, the 93, could be in here. So, it's not good enough evidence. So
Which mean are we talking about? With being within the range of the population mean or sample mean?
the population. So what we construct, you all agree with me, this is a sample mean, correct? That was what we got from, remember, we went and measured dolphin, we did. So we in our heads, we took a sample of 48 dolphins, we measured them, and we got this average, right? This is an idea of where the actual average of the population of dolphins that we got that sample from. So this would be, where's the actual average for all dolphins that live around that island? Where could it be? Anywhere from this to this. Could it be 93? Yeah. So this is not good enough evidence on its own to suggest that their actual length is shorter than it should be. Okay, maybe. Did it take a lot of work to get there? No, that wasn't a lot of work. I mean, a lot of work for statistical analysis would be years, okay? This is not a lot of work. This is surface level stuff. If I still felt pretty strongly, I would go do a deeper dive, right? Literally, in this case. Okay. So, let me ask you this. Looking at your z-score chart, if I wanted to construct a 90% confidence interval, what would my z-score be?
1.645.
And remind me, the one we just did, 95%, what was the z-score?
1.96.
So of course this makes nothing but sense. If I want to be 95% confident that I catch something, so I don't like seafood, but I like this example. If I was going to cast a net out, and I wanted to be 95% confident that I caught a certain fish, right? Can you all imagine there's a lake somewhere? And there's a certain fish. I've been trying to catch this fish for years, right? I'm like, I'm going to catch you today. If I want to be 95% sure that I caught that fish, how much of the fish do I have to catch? No. If I caught all the fish, I'm 100% certain I caught the damn fish. I have to catch 95% of the fish, yes. And then I'm 95% confident that I caught a certain fish. You guys kind of with me? So another way to kind of look at this a little less rigorously is, if I find a sample mean and I go far enough out that I would catch 95% of the data, then I am 95% confident that I caught a certain data point. In that case, what is the data point I'm trying to catch? The real mean. I'll be 95% confident that I caught the real mean in that net. So when I make a confidence interval, that's a net. Throw a net out, one side to the other, that's this. 95% certain that that fish, that mean, is in that net. Are you guys, does that make any more sense? It's a lot less technical, it's a little less correct, but it's correct enough that that captures the concept. So if I want to be 90% confident, my net could be a little smaller. I don't have to go out as far. In fact, I only have to go out 1.645 steps instead of 1.96 steps, because now I can catch less shit. Because I'm okay with being a little less confident. How you guys feeling? I need you to understand
Zero my fish.
this thing. What will a problem look like for you? It'll look like plugging stuff into this equation. Yes? That is the nuts and bolts of constructing a confidence interval. It's just, can you find these things? Can you throw them in? And can you calculate them? That's it. You with me? The derivation always is this idea, the concept is weird. The nuts and bolts of what you're going to have to do as a student, never as bad. So let's do one more example. And then we'll head out. Well, I'll still have some voice. So let's say you're curious about the average grade of stat students.
This sounds familiar.
I'm talking about all stat students, right? So you take a sample of 93 stat students, and you get a sample mean of 79.1. And currently, we have to say that we know this somehow. We somehow know that the population standard deviation. Oh man, there. Sorry, I'm just slowly losing voice.
Are you getting sick?
I've been sick. Okay.
And you're here?
I'm crazy.
It's an immune system test. You got this.
So let's say that the sometimes if you go to a lower register, okay. Let's say that the standard deviation is 12.17.
That's a pretty big swing.
Oh, go home.
And I say, I can do some Louis Armstrong.
Hit puberty.
All right. And I want to construct the, let's say, I can't remember what you have on there, 90% confidence interval. You have everything you need except one thing. What's the formula?
Oh.
Stay over there. What's the formula again?
X bar.
X bar? Plus or minus?
The Z score.
Z?
Your
Square-
standard
Derivation.
divided
Universe square root
by
of n.
or
Do you know
square root.
N?
Yeah.
And
Do you know sigma?
Yeah.
Do you know X bar?
Yes.
We just don't know Z. So where does Z pretty much always come from for confidence interval is how confident you want to be.
That's the 1.645.
Yeah, there you go. So from the little baby chart. Now, you guys have met me before, so you know I'm going to ask you to make like an 88% confidence interval. Is 88% in the little, what I call the baby chart?
No.
Nope. Ha ha ha. So you're going to have to do it the old-fashioned way. 88%, 12%, 6%, look up 0.06, get the z-score. You with me? That's the old way. The baby chart works for the most commonly used interval percentages, right? You with me? And you know I'm a jackass. So I'm going to make you do 88%, 94%.
It's a lot more.
Sometimes,
You gotta
not all
find
the time.
two different z-scores, convert them into percentages, makes a subtraction.
You just find one because it's plus or minus, same number.
Oh, that's right.
And which problem is just like what we're doing right now? Remember the 1.7 and negative 1.7 that was on the practice test, the middle 91%? That's exactly the shit we're doing right now.
Oh, that's what we're going to do. That's what we're going to
No, that's exactly what we are doing right now. We already did it. Well, if I want to be 90% confident, I'm catching the middle 90%, right? How much would be outside? 90% in, 10% out, 5% on that side, right? So I could look up 0.05 in the z-score chart, but the shortcut is, you already know it's going to be 1.645. So make sure you guys understand why. The little baby, the little thing in the corner. If you look at your z-score chart on the positive side, right? Can't remember. If you look at your z-score chart, bottom right-hand corner, for 90% confidence level, what's z? 1.645. Okay. So that little chart did the work for you for some things. So go ahead, do it. Figure out the interval. I'll wait. You got everything you need.
90% or 88%?
90%, sorry.
Is it like from the positive side? Oh my God.
doing okay there. No. Huh? Oh, that's gonna be all right, I think. So let's see, X bar, 79.1, give or take, 1.645 of these. N is always a whole number, correct? Because that's the number of people or the number of whatever. Don't chop people up. That's bad, okay? So don't put decimals in there. If you're putting a decimal in there, you know you're wrong. You chop somebody up, kids. It's not good, right? Okay. Who's got the error? Anybody got the error?
Two point oh eight.
2.168.
Ooh, I got dissension. I don't have a calculator anymore, so
Here.
thank you so much. Did you do it?
I do have a question. How many decimal places do you want that last answer to be? 2 and 3.
Yeah, I'll say in a second. How many decimal places does mean have?
1.
So I want this to have 2, at least.
So 2 for traveling.
Yeah. So I get 2.08. Yeah.
Wait, so is the z multiplication not involved in it? So I multiplied z times.
Oh, it's 12.17.
Yeah.
You got 12.71. See.
So how
What's
many
that?
mean?
Where is it? What did I do wrong?
You just put 12.71 instead of 12.17.
Oh my
That's right. I'm sorry, so it was 2.08?
Yeah.
So again, the rounding rules here are whatever this is, make this one more decimal
No.
place.
It's
The
2.0.
answer.
What?
Your interval.
Oh, we're getting there.
Oh.
Okay.
We haven't got that yet.
So now if you do 79.1 minus 2.08,
77.02.
77.02
Oh, 2. Oh, you want 2 of them.
up to 79.1 plus 2.08,
81.18.
81.18. Yeah.
Can you make the calculator do like plus or minus and give you the range or not?
What's the way to say this? So let me say this. Can I borrow your calculator again?
Remember.
I'm going to show you one thing. Do you see where it says, if you go to stat, it says tests? Sorry. Has anybody ever been curious about that? We've done edit and calc before. But if you go to tests, there's a lot of weird shit. Do you see something at the bottom?
The
Oh,
interval.
1 Z interval? Or what does that say?
Yeah, let's see what it wants from me. It wants input. So it's saying, do you have it in the lists or do you have statistics? I have statistics, right? What was the standard deviation?
12.17.
12.17? And then the mean was
79.1.
79.1. The number was
93.
93. And the confidence level was 90, right? 0.9? 90%? Let's see what this gets. 77.02. Oh, you can't really see that. There it is. Up to 81.18, basically, right? Is that cool?
So that's how you can check your answer.
That's it. See, Bessie knows me. Bessie gets it. That's how you check your damn answer. Right? I always have at least one student say, well, I pushed this button, and then I showed my work. I showed my work. That's what I need to see, right? The formula. And I don't know, part of me doesn't even care, but I really hope some of you guys understand. I have colleagues that have students pushing buttons and they get the numbers. They never look at the formulas. You're not connected to it at all. This little magic box is spitting numbers at you, and you're writing them down, and you have no connection to it at all, right? And some of you guys are like, that would be fine, John. Done. At least you can check your work, yes? Okay. What does this mean?
It's a range.
So you ready for this? Here's the ultimate thing. It's the last thing we're doing today, okay?
Oh,
Every confidence interval problem, you must write a conclusion. Here's the conclusion. We are farmers. No, we are. How confident are we on this problem?
90%.
90%. It's pretty good. We're 90% confident that the interval 77.02 to 81.18. And normally this is where you would put units, but this is just a grade. But you know, if it was feet or whatever, grams of candy, whatever, you put grams. We are 90% confident that the interval 77.02 to 81.18 contains the true mean grade of stat students.
Would you put population mean grade?
Well, that's what I mean by true.
Oh.
So you could say the population mean grade, yeah.
Wait, that would be the 79.1.
Say what? No. What's 79.1? What's 79.1?
Oh, that's our sample.
Sample mean. What are we trying to capture by creating this interval? An idea of where the real mean is. So in statistics, we want to know. So
Wait,
anybody know that there's an election coming up?
Oh, yeah. Hope you
All right. Have you guys seen any polls and such?
Oh, they keep spitting them out.
Yes, they keep spitting them out. What are they trying to capture?
Sentiment.
The actual percentage of people who will vote for blah, blah, blah. Either blah, 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 or blah, blah, blah.
What does that say? Peeps?
Peeps, yes. Students, whatever you want to put there, okay? Yeah, deal with it.
Who says that?
I apparently just did it. So, when they're constructing a poll, they're trying to capture the population percentage. So that's what I call the true percentage of people that will vote for somebody. So whenever you look at a poll, if you find it in the newspaper, actually, no, I don't even look at the newspaper. You find it on the TikToks or whatever. Very often, they will actually have this. Has anybody ever seen they'll say 40% want to vote for this old dude, 45% want to vote for this other old dude, and at the bottom it'll say plus or minus 4%. Okay, that is the plus or minus from this thing. That is exactly so. Section 8.3 is where we're going to build confidence intervals for percentages. So that plus or minus 4%, that isn't just going, hey, how sure are we? I don't know, give or take 4. No, you can calculate it based on how big your sample is, so forth. You can actually see what goes into the error. So the little plus or minus 3, plus or minus 4% is calculated. It's not just, oh no, plus or minus 7. No. It's actually calculated. Are you guys at all with me? You're all like, you said something about leaving early. Just shut up. Okay. All right, that's plenty. So next time, believe it or not, I'll have a handout, worksheet with all the stuff on it. We'll do some examples. Well, that's enough for today. Oh.
One thing we're always going to have to do the closing statement.
Yes, the conclusion. Yes. Yeah, that was the first reaction. That's too bad. Who's there? Oh, Denise, okay. Yeah.
Question though.